In this video, we're going to look at a chi-square test of independence, chi-square test of homogeneity using the TI graphing calculator. So I'm going to use an example that I made up here. At Jensen Land High School, the administration is considering possible changes to its advisory program. So as part of their decision-making process, the administration surveyed their students, asking them whether they would prefer for the advisory classes to meet monthly, weekly, or not at all. So the results of the survey are indicated in the following table, and I don't need to read all those numbers to you, but you can see that we surveyed approximately 95 students from each of the four classes. And the question we're asking is whether the different classes, students in the different classes, have a different opinion on whether the advisory should meet monthly, weekly, or not at all. So what I want to do here is a chi-squared test of independence to determine whether we can conclude that the classes are similar or are not. Okay, so what we might say that for our null hypothesis is that there is no relationship between class in school and their opinion on how often advisory should meet. The alternate hypothesis will be that there is a relationship between class in school and how often the advisory should meet. So what we need to do is calculate our chi-squared value and our p value. So using the graphing calculator, what we need to do is first we go to the matrix and we want to edit matrix A. Now I've been playing with this, so I might already have this information. Okay, matrix A is a 4x3 matrix, and I'm just going to type in the data here. So we've got 45, 20, 30, 50, 15, 25, 45, 20, 25, and 35, 15, and 40 are the numbers. We've entered our data into matrix A. The next thing I want to do is go to Stat, Tests, and we're going to go down this list looking for the chi-squared test. And it's a long ways down here, but when we get down to option C, we'll notice that option C is a chi-square test. Option D is a chi-square goodness of fit test. GOF is goodness of fit. We are doing a test of independence or test of homogeneity. The tests are done the same way. The difference is the setting in which you're doing the test. We're doing a chi-square test. We're going to select option C. We've put our observed matrix, our observed values are these values here. We've put those observed values into matrix A. The calculator is telling us where it will put the expected values. So the calculator will assign the expected values to matrix B. We're now going to simply calculate, and you notice we have a chi-squared value of 9.048, 9.049, with a p-value of 0.171. So if we're doing this hypothesis test, we would not conclude that there is a relationship, but we would reject our null hypothesis. We would say that we cannot conclude that there's a relationship between classes and their opinion on how often the advisories should meet. Okay, so just a quick look there at a chi-squared test of homogeneity or chi-squared test of independence using the graphing calculator.